The next type of functions we are going to introduce for complex numbers are the trigonometric functions. We know that there are 6 of them, together with some of the identities that we can use later on. So we're going to present them one by one. Here, we are going to start with the first 3 common trigonometric functions or ratios for complex numbers. Okay, so let's start with the identity intended for our sine of our z. Take note that z here, a complex number, is what would be our angle. We know that sine theta, for any theta in our real number system, we are actually using sine as actually the value of our y. Okay, or if it's outside the unit circle, we can use y over r, being the radius. This time, our sine of z is represented by this expression, e to the power of iz, okay, minus e to the power of negative iz all over 2I. This is the representation for sine of z. Now, for our cosine of z, this is represented by e to the power of iz, okay, plus e to the power of negative iz all over 2. Okay, so this time we only have 2 as our denominator. Okay, so take note, for cosine we have here plus. And finally, for our third one in this video, the tangent for z is actually expressed, as we know, as the ratio of sine z over cosine z. And since we have the same, we already have our expressions here, this could be expressed as e to the iz minus e negative iz all over 2I over, you have your e iz plus e to the negative iz all over 2. It's actually a nested rational expression, so you can use here the keep change flip method when dividing rational expressions. E to the power of iz minus e to the power of negative iz all over 2I times, you will now have 2 here over e to the power of iz, okay, then plus e to the power of negative iz, the reciprocal of cosine z, which will give us the result. You can actually take out 2 here. So the tangent of z is expressed as e to the power of iz minus e to the power of negative iz all over, you will have your I times e to the power of iz plus e to the power of negative I. So that's I, sorry, let's do it again. That's actually I z. This is the identity for our tangent z. Now, we can also solve for the remaining 3 functions. They will be on the next video. But of course, we know that there are reciprocals of these 3. So we're just going to reciprocate these 3 as well. And again, that will be presented in the next video. Take note for these identities as well, because we have identities for especially the Pythagorean identities together with some even and odd identities, and probably some of the sum and difference identities later on. So we're still going to use the same aspects here. Thank you very much for watching.